Derivative shortcuts for hyperbolic functions, and these are very similar to the formulas look very similar to the derivatives of sine functions. With the trig functions rather, derivative of sine is the cosine, and analogously or similarly, derivative of the sinh is the cosh. There are a few differences with a plus or minus sign. In trig, derivative of the cosine is minus the sine, but for hyperbolic functions, derivative of cosh is a positive. So there are some differences in signs, but otherwise it's the formulas look pretty much the same as the trig formulas. So we can verify this one here, derivative of the sinh of x. That's going to be derivative with respect to x of e to the x minus e to the minus x over 2. The 1/2 comes out in front. That's a constant. Derivative e to the x is e to the x. Derivative e to the minus x. E to the minus x is a composite function, so it's going to be e to the minus x times derivative of the exponent, which is -1, and this becomes 1/2 e to the x plus e to the minus x, and this is equal to the cosh of x. Okay, that's the definition of cosh. So the other derivatives are similar. With the hyperbolic tangent, we can actually express this in terms of sine and cosine, so it's probably easiest to derive that in terms of sine and cosine. So the derivative of a hyperbolic tangent is the derivative of the sinh x divided by the cosh x, and then we can use the quotient rule. So we'll have cosh squared x on the bottom, cosh x times the derivative of the numerator, with the sinh x minus the sinh x times the derivative of the denominator, which is cosh x. So derivative of sinh is the cosh, so this is going to be cosh squared x. Derivative of cosh is the sinh, minus sinh squared x all over cosh squared x. And cosh squared minus sin squared is 1. That's one of the identities. So you have 1 over cosh squared x, which is equal to the hyperbolic secant squared x. So the derivation of these shortcuts is fairly straightforward. Couple of these, the next page, I'll have a minus sign in front. So the derivative of the hyperbolic cotangent is minus the cosec squared. Derivative of the hyperbolic secant is minus sec times tanh. Derivative of the cosec is minus cosec times cos. Okay, so we can combine these with other rules to get some derivatives. Derivative of x plus 3 sinh of 2x. So it's going to be f prime of x will be derivative of x with respect to x plus 3 times the derivative with respect to x of sinh of 2x. Derivative of x with respect to x is 1, and the sinh of 2x is a composite function, so the outside function is sinh, the derivative of sinh is cosh of 3x, and then times the derivative of the inside, so that'd be times 3, times 2. And 2 times 3 is 6, so this is 1 plus 6 cosh of 3x. Okay, so okay, so the So these are fairly straightforward. This is a product rule here. So we combine the product rule with the cost rule with the chain rule. So it'll be the product rule is x times the derivative of cost squared of 2x minus 1 plus cost squared 2x minus 1 times the derivative of x with respect to x. Cost squared of 2x minus 1 is a double composite function. We have outside function is squaring, so it's be 2 times whatever is being squared, which is 2 times cost of 2x minus 1. And then the middle function is the cost. Derivative of cost is sinh. It's going to be sinh of whatever we're taking the cost of. And the inside function of 2x minus 1, its derivative is 2. And dx is 1. So plus cost squared 2x minus 1. 2 times 2 times x would be 4x. Cost of 2, I'm just simplifying this a little bit, cost of 2x minus 1, sinh of 2x minus 1, plus cost squared of 2x minus 1. Okay, so if you have f of x is such squared of 3x, f prime of x, so this is a double composite function again. The outside function is squaring, so this is 2 times whatever is squared, which would be 2 such of 3x. And then derivative of such is minus such times the tanh, so it's minus such of 3x, tanh of 3x. And then the derivative inside, derivative of 3x is 3. So this is times 3. So 3 times 2 is 6, and then we can bring the minus sign out in front. Minus 6. Such times such is such squared of 3x. And times tanh of 3x. This one, a double composite function again. Outside function is squaring. So f prime of x would be 2 times whatever is being squared, which would be sinh of root x. Middle function is sinh. Derivative of sinh is cosh. So the cosh of whatever we took the sinh of, so which is root x. And then the inside function is square root of x. That's the derivative 1 over 2 root x. So the 2's will cancel. And we'll just have 1 over root x sinh of root x cosh of root x. Okay, so that's kind of gives you the idea. There's I have some more. If you want more practice, this file is going to be in Canvas. I'm not going to go over these. These are similar to what I just did, but there's some more examples there. So I think I'm going to stop at this point, and that concludes this presentation.